most important thing an enterprise architect does in his day-to-day is to stand on that bridge between the business and the technologists, translating technobabble into business speak and back again, herding all the cats down the road at appropriate velocity to the same goal. The problem comes in when it comes to getting design intent decisions made that would ordinarily require, for example, your CFO to read a few hundred-page report in order to understand the design intent for an energy-efficient data center sufficiently to approve funding, leaving the granular detail of reading the report and the granular action plans and all the rest to those folks whose job it is to do specifically that. Communicating gross levels of complexity to an executive stakeholder does not have to be the painful document evening it's always been. Modeling provides a different way forward. Sim modeling is based on Google SketchUp. A couple of years ago, Cisco Advanced Services created the Facilities and Energy Management practice, and when I joined that, my role was to develop 3D modeling as an aspect of the tools we have in our tool chest to communicate and to deliver to clients. There is a learning curve, of course, to doing one of these models, and what we're looking at here today is the training data center I created early on in the practice to teach aspiring modelers the basic precision skills of rack and stack in a data hall. In the back, we have a staging area, of course, where we have a variety of Cisco gear. Going into the area, the data hall itself, we have an assignment or two on the whiteboard and quite a few racks to choose from. So the learning curve is reasonably short, and the quality of output is very high and well received by stakeholder groups. So the value proposition for actually doing one of these as part of service delivery was almost like, would you like fries with that, as the account was engaged. And so the salespeople, of course, really loved it. Our models can serve a lot of purposes. This one was put together to provide design intent for the cloud lab that Cisco built in Richardson outside of Dallas a few years back, and then subsequently for use by the account teams to introduce their stakeholders who they're trying to line up to come to Richardson for the day's events. The nice thing about the model is we geolocate it, of course, and so the account team can take their folks from the highway into the campus, around to the building, to Richardson 6, where the lab is, and then take them through the whole process of security check-in and around to the lab where they're going to be. And so you're managing that part of the day that is most difficult to manage, where your stakeholders are in the hotel room and then getting them into the room on time so that you can start your day here, in this case at Richardson in the Cloud Lab. You can greet them with a message on the whiteboard. But for the account team in particular, we have the ability to talk about planning for the day as well. For example, we have displays on the wall for operational telemetry that's coming off the machines. Who's going to sit in this spot? Who's going to be sitting there and looking at all of the displays for operations? Of course, that's your ops guy. At the head of the table, chairing the telepresence, might be your chief executive stakeholder. Now, here in the middle seat, somebody gets to stare at the kit, and I'm betting that's your infrastructure folks. Taking the model just a little bit further, we can then talk about the kind of kit that's going to be on display. behind the glass that they're going to be seeing. We can discuss the way the lab has been put together, and also that we use this model to each component carries metadata, so we can provide design intent for power, cooling, and the impact of various load factors. And of course, there is always what everybody likes to talk about, that's the technology and the kit. Models are very powerful in communicating very difficult, very complex topics to visualize outcomes of decision making. This one has been particularly useful. So one thing these models are really good at is to visualize complexity and communicate it in such a way that even people who aren't really technically conversant can understand some pretty twisty topics. This particular model was done as part of a data center assessment for a cap case, which for Cisco was one of those flaming fire drills, all hands on deck kinds of affairs. And in this case, it was a data center contamination event. We submitted a report, of course, but this was accompanying it in order to let the stakeholders understand the kinds of things that they needed to address directly and where the main problems were for their particular data center. We would have ordinarily geolocated this so they could understand exactly what the current environmental conditions are. All we can say for this is that it was in the western United States, that it was an early free air design, air economizing, and that at the time of this event there were a handful of wildfires in the area, and the local air quality was a known issue. So what we did here was to first lay out the air tunnel system underneath the data center, and that's what we're looking at here. And when we inspected it, we found that there was contamination down the south end, and it lessened the further north you went up the data hall, the air tunnel rather. Being an early free air design, it was designed by, at the time, really, office architects, office building architects, and not data center architects. And the filtration system, they were MERV 13, I believe. They needed to be at least 17, HEPA or better. For example, there were parts of this concrete which weren't exactly sealed properly at build time, and if you ever tried to control humidity in your basement in the fall or winter with concrete walls, you know it's a pretty difficult thing to do. They also had, at the north end of the air tunnel system, a suppression system. They had disassembled that and moved the gas canisters, as you see them down here on the south end, waiting disposal. In the interim, though, they're sitting here in front of the blast of the air handlers, and they were collecting deposits of contamination on the top, which would either be blown into the data hall or allowed to or enabled to grow, as the case may be. The tunnels connecting the electrical systems on the other side of the data hall. The south one was fairly heavily contaminated. The north one, however, was pretty clean. And so what we were able to determine was that in the south end of the data hall, which is what you're looking at here, there was a sweet spot for the contamination, which coincided to where the event occurred. And we were able to discuss also in the context of energy management. These are normal fluorescent lights, and they really threw off a heck of a lot of heat in there, along with the other problems they had with thermal management and other kinds of standard references for a data hall. They had a lot of problems that were discovered and illustrated in these heat images. We were able to deduce, actually this was fairly interesting, and it's almost like a storm front, and for this particular failure it genuinely was a factor in the failures, as the change in the rate in humidity exceeded ASHRAE standards, and compressed air against the power supplies, liquefying the sodium deposits. So it's very interesting problems, and we were able to also demonstrate the hypothesis with the failure pattern. And this in the 3D model is very powerful. A 100-page report, or the essence of it in a model. So it resonates very well. Why don't we go back now? Something that really is an aspect of sim modeling that makes it stand out, as I said, education. Now, when was the last time somebody explained to you what it is that NAS storage does and how it gets from where it is to where your server is on a UCS? How about getting to the SAN and getting to protected storage to getting out into the WAN anyway? The point here is that you know what I'm talking to, what aspect of this model I'm discussing at the moment, because of the animation, of course. And think now to the last time that someone presented a concept to you that was something as complex as highly available topologies, and you really wanted to understand what all of these wires and boxes and loops were. This makes it a lot less tedious, a lot more consumable, especially when you don't know for sure the expertise level of your audience, for example. And so we go through all of the different constructs for VMDC's differentiation and so forth. There's a lot of ways to talk to these things. And at the end of the day, I think the biggest impact as an education tool is over on the data center floor, where now we can take a look at the rack and stack and see what it actually will look like as it comes into the data center. We put this together as if it could just parachute in, fully self-sustained, power, cooling, and row, and all that kind of stuff that you see here. So we did also introduce, for example, the FlexPod. For people who really love PowerPoint detail and linear thinking, the bill of material from the CVD is right here, and we can certainly get up close and discuss what's in this, if that's part of what the education is that you're using this particular model for. We did, of course, have to have two different ways of cooling this space because facilities and energy management, that's what we did.